Thanks everybody for joining in. It's 10:58. We'll wait until 11 to get it started. My name is Alex Zamses with Belzona, Houston. Just going to give everybody time to trickle in. I'm sure some people will show up right at 11 a little bit later, and we'll start the webinar. Thank you. All right. Well, it's 11 o'clock. I'm going to go ahead and get started. Like I said, my name is Alex Zamses. I work with Belzona Houston, VP of Technology here. And today we're going to talk about aggressive chemical applications. So in this presentation, we're going to cover Belzona lining background. So we'll go into some of the liners we have, chemistries we have. We'll go into the chemical resistance of epoxies, which is our main liner that we use, and then go into specifications, case histories, and of course, quality assurance. So starting off, our liners. So when we think aggressive chemicals, we usually think about liners, coating the inside of a vessel, pump, reactor, tank. There's also other things that can be repaired and fixed, and chemicals are going to come in a wide variety of types of chemicals and type of equipment and operating conditions. But going into our liners, we're going to mostly consist of two-component thermosetting Novolac epoxies. So we have thermoset polymers, and I'm going to get into thermoset versus thermoplastic in the next slide. But being that we have thermosetting polymers, that means that they're irreversibly cured, so you can't remelt them and reform them. So they are, once they're cured, they don't melt, and that's part of having chemical resistance, and we'll get into that in the next slide. And just to have some background, our products are mainly mixed, a part A, part B. Some people call them part A, part B. Some people call them base and solidifier. Some people call it a base and a hardener. But basically, you mix two components and they are in liquid state. And once they cure, they form a hard polymer or plastic liner on the inside of the vessel. It can be on the outside of a pipe. It can be a lot of different scenarios. So what we're using is a polymer, and I'm sure everybody's familiar with polymers. There might be some people here that work at polymer plants that make polymers all the time. And as we know, they're all around us. Polyethylene, for example, water bottles, bags, food containers, we all use polymers every day, plastics, but they're not all created equal. So just because you have two polymers does not mean they have any of the same mechanical properties whatsoever. For example, if we look at PVC or polyethylene, that's going to be what we call a linear polymer. If you look at the bottom left picture, that's figure A. So the long chain, which polymers, if you look at the first note, it's from Greek origin, many parts. So you have one repeat unit, such as ethylene, you put it through a reactor, and you form a lot of different ethylenes attached together, which forms a macromolecule of polyethylene. Not to get too involved into that, but linear polymers are going to be, a good way to put it is bowl of spaghetti, a bunch of long molecules that are connected via some forces, but not really branched together. So you're going to have flexibility. They're going to be a little softer. They're going to be thermoplastic, which means you can melt them and reform them. And then as you move down towards figure D, they become more branched, like figure B is going to be branched. So they're a little bit more dense, a little bit more stiff than your linear polymers, something like HDPE, but they're still thermoplastic, so you can still melt it and reform it. Part of the reason why you can weld HDPE, and that's how you weld together fittings. And then as you move towards figure D, they become more cross-linked, which is a huge word if you're in the epoxy business. For chemical resistance, we have a highly cross-linked network, but basically those long chains of polymers are connected together with covalent bonds, which makes a really tight, strong structure network. And that creates a rigid product that gives it a lot of high heat and chemical resistance. So it makes it a very tight net. That's one thing that I've been told by R&D. They try to explain it to us. They have a tight fishing net so things can't get through it. But basically, just so you know, different polymers are going to have different molecular structures, and that's really what's going to give them their properties that they need to have the chemical resistance that you want. So to keep it simple, what we do in, you have the R&D team that's going to know all the chemistry and try to create that tight cross-linked character epoxy, but we're just going to put it through a simple test. A simple test would be ISO 2812-1. You have coated rods like you see in this picture. You put them in a vial with different chemicals at different temperatures and concentrations. You leave them in there for a year. You check them every couple of weeks and make sure that they're not getting attacked. So Belzona, we came up with a system. The red on the bottom here is outside of the picture, but that's a poor rating. We have a moderate rating, a good rating, and an excellent rating. And all that is based on this internationally recognized test, which is ISO 2812-1. So we try to test as many chemicals as possible. At times, we're going to test the most aggressive chemical that we can use that's safe to test. That way, it gives us a good judgment chemical so we can test. There's so many chemicals, you can't test them all, but maybe we test the most aggressive one we can get. That way, we know if there's similar chemicals that are going to be less aggressive, we'll know that we'll be good versus that. Another test that's good for both immersion and chemical resistance can be NACE TM0174, which is an Atlas cell immersion test. Again, it's pretty simple. You get two flat plates, you coat the insides of them, you glue them to this Atlas cell here, and you immerse these in water at a specific temperature for 6 months. You're going to check it monthly, make sure there's no cracking, no delamination, no permeation. So the samples are going to be assessed both qualitatively and quantitatively. So they can even test for resistance and weight to see if it's absorbed any water. Now you can run this test with water, which is the normal fluid. Normally you're going to run it with deionized water, which is adds to the permeation because it doesn't have any salts and such in it, so it acts as more of a solvent. But you can also run this with chemicals if you have a specific chemical that you wanted to test, and you can also run this at high pressures with a steel Atlas cell. And again, there's a lot more testing other than chemical resistance because aggressive chemicals usually come with aggressive cleaning services. It might come with high temperatures, high pressures, might come with solids. So we got to make sure that we have good adhesion, we have good immersion, permeation, chemical resistance, but we want to have good steam out resistance because we know these vessels might get cleaned out during turnarounds. We do a lot of different tests to make sure that we can handle everything that goes on. Because if you cannot handle anything that goes on, you result in chemical damage. So, I looked into some research. Definitely, I know what can happen if you put the wrong coating and the wrong chemical. But basically, what happens is first thing that happens is a permeation of the chemical into the coating. So the coating cross linkage is not good enough to handle the chemical, and it's going to start to permeate through the coating. Over time, the coating is going to absorb the chemical and result in swelling, which is going to result in blisters. Usually is the first thing that pops open. Then it goes to delamination and cracking. Something you see with strong acids at time is also erosion, so it might just erode the surface over time. So this right here, what you're looking at is what can happen if you possibly put the wrong coating with the wrong chemical. So we definitely do as much testing as we can and work on specifying the correct product for the correct application. So good question is, how do you increase chemical resistance? Well, the first thing every company tries to do is improve their formulations. So we've been a company in, Belzona's been around since 1952, kind of the forefront of epoxy linings, and we're constantly looking to have that next best epoxy liner. So they're always working on it. Right now, we have a coating that can handle about 320 to 350 immersion with a lot of different chemicals. But another way to increase your chemical resistance is to post cure your product. So remember I talked about cross linkage, making that molecular structure as tight and bonded, all the chains bonded together. You want that to be as tight as possible. Well, one way to do that is actually to increase the heat during the curing stage. That's going to increase the molecular mobility within the coating, and it's going to make your conversion rate go from, let's say, 70 to 98%. Because at ambient temperature, there might not be enough energy for all the molecules to react with each other. It's kind of like if you're in a parking lot and it's 90% full, it's hard to find a parking space. So we need to give it some energy, give it some heat, and those last 10% will find their parking space. So that's definitely something that we do. If you're looking at this picture right here, we have our AC and heating duct into this tank. This tank was lined with a acid resistant coating, and we specified a post cure. So we got the tank to about 150, 170 F after the application to post cure it and get that cross linkage, more cross linkage within the coating. So you can do all the right things, create the best product, but if you don't specify it correctly, it's not going to work. So you definitely want to work with us, and we work with our clients and to make sure we fully understand the process. Especially for liners, there can be additives, there can be potential upsets, there can be turnaround cleaning processes. What happens during shutdown and startup? Is there a surge to 500 degrees F? Are you cleaning your process with bleach at the end? Are you adding bleach to your process? So there's always little details that can make a difference, and we, work with our client to specify everything, specify the correct procedure, and really put the best product down. We're always looking to make it the most cost effective, but a little thing such as an addition of acid every 2 weeks can change that specification. Once you have the specification in place and we've chosen the right product, everybody's happy with the compatibility between the product and the service. It's really important to come out with a procedure and an inspection test plan, or ITP. So within that, we can figure out a lot of the logistics. When are we going to install this? What do we need to do? If it's in the winter, we might need to have heating and insulation, to keep the vessel at a certain temperature. If it's in the summer, we might want to have AC and dehumidification. So little things like that are going to make the process go a lot better. We want to definitely have all our installation steps, our hold points with our inspection team. So are we going to work with your inspection team? Are we doing the inspection? Normally it's a team effort between the both of us. And then of course the curing. So if it's a chemical that we feel like we need a post cure, we need to increase that cross linkage, we'll specify a post cure. And then of course figure out who's going to do the project. We do turnkey. We also provide training. This is a pretty standard job in our industry, coatings. So there's a lot of qualified contractors out there, but it's always good to have a little training, go through the products and the different things that go with it. Once it's being installed, documentation is the most crucial. Make sure that all the T's are crossed and I's are dotted, and make sure all the QA/QC is documented and that everything adheres to the specification. So we're going to specify all the manufacturer's recommendations so that the products perform to their spec sheets. So we have to make sure that it's applied right in the field. We don't want to skip any steps and coat an aggressive chemical and then skip a little mistake that's going to cause an issue down the line. So going into some case histories, this was a sulfuric acid tank, 92% sulfuric acid, alkylate, and the vapor phase isobutane on top, part of their alkylation unit. This was a tank that was right at the end of its life, and they wanted to extend it another 10 years. Had pretty bad corrosion along the welds. some pitting at the manway, and it also had some through wall defects at the manway as well. So we did some external repairs, but on the inside we coated it with a two component epoxy liner that can handle everything in the tank from the 92% sulfuric to the alkylate. It was a sprayable liner, and then the little details. So it did have some nozzles that were 3 inch and below, which I'll get to in the next slide. It did have some deep pitting at the weld, so we had to use some pit fill material, and it had some external issues, so we did some external repairs as well. But for nozzle inserts, any nozzle that's 3 inch or below, it's going to be tough to coat. Just in a manageable physical sense, you can't see it that well, you can't reach it that well. You can stick your blast nozzle in there and give it a good blast, but you can coat it with the roller 3 times, but you'll never be certain that you have the correct dry film thickness and that it's pinhole free and coated correctly. So one of the ways we take this doubt out of the game is using our nozzle inserts. So this is where we get the spec for the liner. Belzona 1593 is going to be used to line this tank. So we'll make the nozzle insert out of 1593. So the blue part on the inside, that's 1593. Then we'll build it up with one of our paste grade materials, and then we glue it in with 1593. So it's a tube made out of Belzona, glued in with Belzona. So the nozzle has a continuous coating. We're pinhole free. We have the correct dry film thickness across the nozzle, and actually a little bit more than we need because of the paste grade. So this is a way to ensure that we're not going to have an issue down the line at the nozzle, which is mainly where you see issues in coatings. And non-coated vessels as well usually have issues at the weld of the nozzles a lot of times as well. It's definitely our bulletproof way of finishing the specification. Going into another example, another chemical that can be aggressive is methanol. Methanol is a fairly small molecule, so it's able to permeate the molecular structure of coatings, and that's a general thing. Is smaller molecules are going to be a little more aggressive than a larger molecule towards coatings. So methanol, you definitely want to put the right coating down. So this was Belzona 1331, which was tested and was excellent. This tank was operating at 42F, so if it was operating at a higher temperature, we would have had to specify one of our high temperature coatings. So 1331 is rated up to about 122F. So we were fine using that here. We had to do some pit fill. As you see, the metal was, scattered pitting throughout. Going into high temperature, we had a knockout drum here, which was operating at 250F, suffering from corrosion due to exposure to a mixture of hydrocarbons, ammonia, water, and lead carbon dioxide. Now, the reason I like to show this one is because there are some chemicals that are actually aggressive towards steel, whereas they're not really that aggressive towards their coatings. And some of them that come to mind are carbonic acid and H2S, which are, troublemakers in the steel industry, definitely cause corrosion issues. But as far as aggressiveness towards coatings, they're not strong acids. They're fairly weak acids, and they don't really attack our coatings very much. They're not, some of our low tier coatings can handle these very easily. So when it comes to acids, the stronger acids are going to be more aggressive towards coatings, whereas the weaker acids are not going to be as aggressive to coatings. But I would still consider this an aggressive environment, being that it's at 250F. Epoxy liners generally top out in the 350 to 400F range. So 250 would be considered a high temperature application. And you do have ammonia, which is also another chemical that can be aggressive towards some epoxies. But other than that, hydrocarbons, C1 through C5, not very aggressive towards epoxies. And wet carbonic acid and water, not really an issue when it comes to most epoxies. Now, so far, everything's just been protecting the vessel. But one thing we also do is repairs. So you can have pipes that carry these aggressive chemicals, and we can fix those if they're thin wall or leaking. This was an example of a amine pressure vessel that had a crack at the weld, so it was causing leakage. This was cracking due to presence of chlorides, which was due to a small concentration of HCl. HCl, hydrochloric acid, is going to be an aggressive chemical towards coatings, and amines can also be aggressive. So you have to make sure you're using your high grade coatings when it comes to some amines. So here we had amines, small percentage of HCl at 250 and 200 psi. That's high temperature. That's also high pressure for coatings. So you definitely want to apply everything correctly, do the best possible surface prep, and use the best possible product. So here, since we had a crack and through wall defect and leaking and high pressure, we did a composite repair on the outside and a composite repair on the inside. Once the composite repairs were installed, we sweat blast everything and apply a two coat system that can handle the chemicals at the temperature and pressure. So the composite is to give it structure, to give it leak tightness and hoop strength. And then the coating is to protect the composite and protect the metal from further degradation. So we all know we're in the chemical industry, and you always got that secondary containment. So we're not, there's always going to be some spillage, transfer of chemicals. So there's always that concrete that gets beat up. And I like to put this at the end. Just this is definitely what we see as, aggressive chemical attack is definitely seen in the secondary containment worlds. And we have a lot of solutions for it. So you can see here, this was several concrete bonds that had corroded due to strong acid and alkali solutions. With concrete, it's crucial. You want to clean it, neutralize it, and prep it right. So you want to remove any loose concrete, clean it real good, roughen it, and have a nice intact structure. Then we can rebuild it, coat it, and protect it so that it doesn't get damaged anymore by chemicals that are going to spill on it. And definitely, this is something that's been picking up a lot and always been an issue over the years. Your assets are always protected first because they're your crucial primary containment. The secondary containment over time, that can lead to huge issues and environmental issues and high cost of having to redo concrete. So we can come in and protect it and make it last a lot longer than it would have without any protection. And this example, for instance, we also used our concrete rebuild products to create the proper slope to make the drainage correct again too. So we can work with slope, we can work with protecting the concrete, rebuilding it. So yeah, definitely a big aspect and big systems that we use all the time. So yeah, pretty much from the inside, to the outside of a pipe, to the secondary containment, we try to have a full comprehensive system for aggressive chemicals. We have our chemical resistance charts that show our resistance towards the chemicals that we share with our clients whenever we have to. We're very upfront with chemicals. If there's something we think we can't handle, we'll let you know. If we think that it has a chance, but we're not sure, maybe we can run a test with you guys. And if we have the tests available, we'll definitely be happy to share it with you. And we have a lot of case histories that can help to determine the most reliable solution. So any questions? Thanks everybody for joining in. And if you haven't so already, this is a continuing education credit. If you put your name and email in the chat, we'll go ahead and send you your 1 hour continuing education credit. You can also put in any questions in the chat as well. And feel free to email us at any time. You should have a rep. If you don't have contact with him, or you don't know who he is, please email our office at belzona.com and we'll belzonahouston.com and we'll put you in touch with them and be happy to help with whatever scenario you guys have.
Hey, Alex, can you hear me?
Yes, sir.
Hey, man, I appreciate the presentation you put together and, going in a little bit more depth in regards to how the different links are formed and how they're more effective in the different services. You guys recently did one for us. I think the filler you used was a 1511. and then I think the liner was a 1593. So,
Yep.
and you guys installed it at your shop. So I know from experience working with you guys that was a good experience, and we got the asset back, and we'll be here before long. Here in a couple of months, we'll be taking another look at it to see how that material performed. But definitely pleased with the installation.
Awesome.
Um,
That's great to hear.
Now I got the question.
All right.
I thought it was very interesting when you were talking about that pressure vessel. You indicated that it was found with cracking, and you guys did a composite repair. Um, my mind kept going on that. So just the only question that I had, was there anything done to mitigate that cracking, or did you guys just put your system on it
So
to reinforce it?
that's a good question. So that one we actually were able to drill and tap the
Perfect.
crack. So we used the first picture. It had the dye penetrant,
Right.
and we found all the cracks, and we drilled the ends, and then drilled every inch or so, and put in set screws in the crack, and then filled it with the putty that you guys use, the 1511, and then we did the composite wrap, and then we top coated it with the 1593, which is the same coating you guys use, and that's our high temp product.
Yes, yes. So
So
my
yeah,
last
definitely
question,
if you can drill out the cracks, that's gonna stop the propagation because the composite itself won't really stop it from growing axially.
yeah, that's the reason I had to ask. My last question, I know that you guys have that site where we can send I can we sent stuff off and you guys have applied coating there. What I can't recall is, do you also, I know you said you train folks, so I'm going to take that to mean that you probably have employees that could come on site and install the material if needed.
Yeah, so we have a full turnkey service, like our
Right.
the same people that we had that you know installed it here at the shop. And I mean, we can do it a bunch of different ways. Like I run the trainings here. So if you had five people that wanted to learn how to do composite wraps, we did a training yesterday. They can come here and learn how to do it. Or I mean, we could send a couple guys and they can work with whoever is installing, as a helper slash supervisor role to like, teach them on a job how to do it. So there's a lot of different ways that we can do the training. The most traditional way is either I come to the facility, bring product, and we mix it up and use it, or your team would come here and we use the product here. So there's definitely yeah, we definitely come on site, full turnkey, come on site to help your team or do
Perfect.
traditional training.
Gotcha. Gotcha. I appreciate it, Alex. Thank you, sir.
Thank you. Have a good one.
Yep.
Any other questions? Well, thanks everybody for joining in. Hope this was useful for you. If you have a topic that you would like us to cover for the next webinar, we can do it. We do it once a month, and we're happy for you guys to join in. So we'll keep you tuned for the next one, and hope to see you guys there.